Now, the second important law of fluid statics is hydrostatic law. Now, this law also called as pressure density height relationship. Now, let us say we have a static fluid. Say we have static liquid here, and this is the bottom line we have. So now we consider a cylindrical fluid element into this fluid static condition. So we consider a cylindrical fluid element. Now the bottom surface of this cylindrical element is at distance y from the bottom, and this length of this element is say y. The top surface is at length, now say this is y, or another way you can say it as the top surface is at height length y2, and the bottom surface is at length y1 from the bottom. Okay, so this is we call as point 1 or surface 1, and this is surface 2. So in general way we can call as y and say this is dy. The length is dy, very small length. Now this element is under fluid static condition. So this experiences two type of forces, pressure and the weight. Now let us say P be the pressure intensity acting on the bottom face, and on the top face the pressure intensity is say somewhat higher than this P, that is P plus curly P by curly Y into dy. Now the meaning of this curly P by curly Y dy is, now there is small increment in P with respect to direction Y. So this is how we can write it as in mathematical term, the small increment in P along height Y. So that we write as curly P by curly Y into dy. Okay. Now the third force which acts on this element is the weight. That weight acts in the downward direction. Okay. So now we balance the forces. So the force acts in the upward direction, that is P into area of the base. Now say the area of this cylindrical element is dA. So we can write as the upward force as P into dA. This is equal to the downward pressure force by this pressure intensity. So P plus curly P by curly Y into dy into dA plus the weight of the element. Now weight of this element we can write as the specific weight of the fluid. Now say this fluid having specific weight W multiplied by the volume of the fluid. Now further, the volume of this fluid element is, now this is the cylindrical element, so volume we can write as dA area into the height dy. So W dA dy is the weight of the element. Okay, so now we can write it again as P into dA equal to P into dA plus curly P by curly Y into dy into dA plus W dA into dy. Now this dA cancels with this. So we left with curly P by curly Y into dy into dA equal to minus of W dA into dy, or we can write it as now dA dy cancels out. So W is equal to minus of curly P by curly Y. Okay, so that means the specific weight is equal to the rate of change of pressure intensity along y direction. Now, if we say the intensity of pressure varying only along y direction, then we can replace these partial derivative with the exact derivative or exact differential, that is as dp by dy. So if p is varying only along y direction, so we can write as w is equal to minus dp by dy, or dp is equal to minus w dy. Okay, so this is the second fundamental relation between pressure, specific weight that depends on density, and the height of the element. So this relation represents the hydrostatic law. Okay. Now this equation indicates that there is negative pressure gradient exists along upward, that is our vertical direction. So that means pressure decreases in the upward direction, or you can say pressure increases in the downward direction. So this is our upward direction. So in this upward direction, pressure decreases. Okay, and this is the downward direction. So along this direction, pressure increases. So that is the hydrostatic law. Okay. Now further, if this dy is 0, the meaning of that is if we say dy is equal to 0, the meaning is now our fluid element is like a surface. So over there, from this equation, you can say dP is equal to 0. So along the surface, pressure is constant. So you can say the pressure is constant at the same level. Okay. So these surfaces where the pressure remains constant along the horizontal directions, these surfaces we call as isobaric surfaces. Okay. Or we can call it as equipotential surfaces. So these are the horizontal planes or horizontal surfaces. Okay, so this is the second basic law of fluid statics, that is the hydrostatic law.